Hume's principle, or HP. The terms were coined by George Boolos. Says that the number of f's is equal to the number of g's if and only if there is a one-to-one correspondence, a bijection, between the f's and the g's. HP can be stated formally in systems of second-order logic. Hume's principle is named for the Scottish philosopher David Hume. HP plays a central role in Gottlob Frege's philosophy of mathematics. Frege shows that HP and suitable definitions of arithmetical notions entail all axioms of what we now call second-order arithmetic. This result is known as Frege's theorem, which is the foundation for a philosophy of mathematics known as neo-logicism. Origins. Hume's principle appears in Frege's Foundations of Arithmetic, section 73. Which quotes from Part 3 of Book 1 of David Hume's A Treatise of Human Nature, 1740. Hume there sets out 7 fundamental relations between ideas. Concerning one of these, proportion in quantity and number, Hume argues that our reasoning about proportion in quantity, as represented by geometry, can never achieve perfect precision and exactness, since its principles are derived from sense appearance. He contrasts this with reasoning about number or arithmetic, in which such a precision can be attained. Algebra and arithmetic are the only sciences in which we can carry on a chain of reasoning to any degree of intricacy, and yet preserve a perfect exactness and certainty. We are possessed of a precise standard, by which we can judge of the equality and proportion of numbers, and according as they correspond or not to that standard, we determine the relations, without any possibility of error. When two numbers are so combined, as that the one has always a unit answering to every unit of the other, we pronounce them equal, and it is for want of such a standard of equality in spatial extension, that geometry can scarce be esteemed a perfect and infallible science. 3. Note Hume's use of the word number in the ancient sense, to mean a set or collection of things rather than the common modern notion of positive integer. The ancient Greek notion of number, arithmos, is of a finite plurality composed of units. See Aristotle, Metaphysics, 1020a14 and Euclid, Elements, Book 7. Definition 1 and 2. The contrast between the old and modern conception of number is discussed in detail in Maybury, 2000. Influence on set theory. The principle that cardinal number was to be characterized in terms of one-to-one correspondence had previously been used to great effect by Georg Cantor, whose writings Frege knew. The suggestion has therefore been made that Hume's principle ought better be called Cantor's principle. But Frege criticized Cantor on the ground that Cantor defines cardinal numbers in terms of ordinal numbers, whereas Frege wanted to give a characterization of cardinals that was independent of the ordinals. Cantor's point of view, however, is the one embedded in contemporary theories of transfinite numbers, as developed in axiomatic set theory. Anderson, D. and Edwards Alter, 2004. Frege, Boolos, and Logical Objects. Journal of Philosophical Logic 33. 1-26. George Boolos. The Standard of Equality of Numbers, in George Boolos. Ed. Meaning and Method. Essays in Honor of Hilary Putnam. Cambridge Eng. Cambridge University Press. 1990. pp. 261-277. George Boolos. 1998. Logic, and Logic. Harvard Univ. Press. Especially Section 2. Frege Studies. Quote. Burgess, John. 2005. Fixing Frege. Princeton Univ. Press. Gottlob Frege. The Foundations of Arithmetic. David Hume. A Treatise of Human Nature. Maybury. John P. 2000. The Foundations of Mathematics in the Theory of Sets. Cambridge. Stanford Encyclopedia of Philosophy. Frege's Logic, Theorem, and Foundations for Arithmetic, by Edward Zalter. The Logical and Metaphysical Foundations of Classical Mathematics. Quote, Arsh. The Center for Philosophy of Logic, Language, Mathematics and Mind at St. Andrews University.